Hi, this video is the answer key for Test 1 in Math 111, which was held in fall of 2020. Here are some instructions to take advantage totally from this work. Before watching this video, try to work on this test in your own. Put yourself in exam conditions, take 90 minutes, and don't use any calculator or any support. Then check what you can do. Once you've done, color in green questions which you think you made right, in orange questions in which you doubt about your answer, and shade in red questions which you found hard and challenging. Now, you can watch this video and get yourself in the mood, not only for watching, but also for learning, processing new information, and remembering as much as possible out of it. Now verify your work. You have to take care first of all questions which you shaded in green. Verify if you really answered them in the right way. If not, you have to focus on the solution and correct your misunderstanding. Then compare your work with this answer key for questions which you shaded in orange, and try to enhance your computational skills. Finally, go step by step while watching the solution of a red shaded question, and try to work on it again once you think that you acquired the needed skills and understood how to deal with it. That way, you will be sure that you increased your math level and enhanced your computational capacities. Now you can enjoy this video. In the first question, we have to perform the indicated operations and simplify the expression minus 2 times x plus 1 squared minus x squared plus 1. As a first step, we should expand the term x plus 1 squared, which gives x squared plus 2x plus 1. Then, we distribute the negative sign on the term x squared plus 1, and we get minus x squared minus 1. Now we simplify the terms x squared with minus x squared and 1 with minus 1. So we get minus 2 times 2x, which is equal to minus 4x. So the right answer here is B. Question number 2. If x is greater than 1, the expression 1 over 5 times the absolute value of 3 times the absolute value of x minus 1 minus 6 times the absolute value of x minus 1 minus 12 times the absolute value of x minus 1 equals one of the following choices. Let's first denote by A this expression, and we denote also y equals the absolute value of x minus 1. I use this notation to make things simpler for you. So the expression A will be in the form of 1 over 5 times the absolute value of 3y minus 6y minus 12y. So as you see here, the computation is simpler. Now adding 3y minus 6y minus 12y, we get minus 15y. So you know that the absolute value of A times B equals the absolute value of A times the absolute value of B, which gives 1 over 5 times the absolute value of minus 15 times the absolute value of y. So we know that the absolute value of minus 15 is 15. Also, the absolute value of y equals y. Since y equals the absolute value of x minus 1, so it is already a positive number. And this gives 3y. Now, coming back to the expression of y. Now, for x greater than 1, we know that x minus 1 would be positive. So we conclude that y equals x minus 1, since x minus 1 is positive. As a conclusion, A equals 3 times x minus 1, which is equal to 3x minus 3. So the right answer here is A. In question 3, we consider 3 sets A, B, and C. Which one of the following is true? The first choice is obviously wrong, since 7 is not an element of A, which contains 1, 3, and 5. The second choice, it is true that 1 is an element of A, so the problem here that we used the wrong operator, which is belong. Instead, we must use subset, since we have to compare here between two sets. As you see, 1 is between two brackets, so here 1, it's not a number, so it's not an element, but here we have the singleton 1, which is considered as a set, so that we have to use subset instead of belong. For A union C equals 1, 3, this is also wrong, since with a small computation, we can see that A union C equals the set 1, 3, 5, and 7. So this is not equal to the set 1, 3. Now, as a conclusion, we deduce that the last answer is the right answer. Let's verify it. So we have B intersect C is a subset of A intersect C. B intersect C equals the singleton 3. As you see here, the only element which is in common between B and C is 3. Whereas A intersect C equals the set 1, 3. And we know that the singleton 3 is a subset of the set 1, 3. So we deduce that B intersect C is a subset of A intersect C. Question number 4. The imaginary part of x plus y when x equals 1 minus 2i and y equals 3 plus 7i is. So as you see here, we are asked about the imaginary part only. For descent, we will just make a small computation, writing x plus y in standard form. Now, very simple computation gives that x plus y equals 1 minus 2i plus 3 plus 7i. And we get 1 plus 3 plus minus 2i plus 7i, which gives 4 plus 5i. So as you see here, the imaginary part is 5. So the right answer here is C. Question number 5. Write the quotient I plus 1 over I divided by I minus 1 over 2i plus 3 in standard form. So in the beginning, we should know that the division by a fraction means that the multiplication by the inverse of the second fraction. So we get I plus 1 over I times the inverse of the second fraction, which is 2i plus 3 over I minus 1. Now multiplying two fractions, it's numerator times the numerator and denominator times denominator. To get I times 2i, this is 2i squared, I times 3 plus 3i, 1 times 2i plus 2i, and 1 times 3, which is equal to 3. Whereas in the denominator, we have I times I, which is I squared, and I times negative 1, which is minus I. Now, remembering the fact that I squared equals minus 1, the numerator would be 2 times I squared equals minus 2, 3i plus 2i will give 5i plus 3. And in the denominator, I squared will be minus 1 minus I. Now adding the real part together in the numerator, we get 1 plus 5i over minus 1 minus I. To write this fraction of complex numbers in standard form, we need to multiply the numerator and the denominator by the conjugate of the denominator, which is minus 1 plus I. Now we expand again. 1 times negative 1 equals minus 1, 1 times I equals plus I, 5i times negative 1 equals minus 5i, and 5i times I, this is plus 5i squared. Same thing for the denominator, so we have negative 1 times negative 1, this is 1. Negative 1 times I, this is minus I times negative minus 1, this is plus I, and negative I times I, this is minus I squared. So after small simplification, using the fact that I squared equals negative 1, the numerator would be minus 1 minus 4i minus 5, and the denominator it is 1 minus minus 1. Minus 1 minus 5 gives minus 6, so we get minus 6 minus 4i divided by 2. Now we split this fraction in two terms, so minus 6 divided by 2 is minus 3, and minus 4i divided by 2 it's minus 2i. So the right answer here is C. Question number 6. The radical expression square root of x squared plus 2xy plus y squared equals. So here, as you see, x squared plus 2xy plus y squared, we can write it as x plus y squared. Now, using the rule that the square root of z squared equals the absolute value of z, we get as a final answer the absolute value of x plus y. So the answer here is B. Question number 7. Rationalize the following expression: 3 square root of 14 minus 4 square root of 63 divided by 3 square root of 7. The term rationalize here means that we must get rid of the term square root of 7 in the denominator. For this end, we will split our work in some steps. First of all, we can see that 14 equals 7 times 2. Also, 63 equals 7 times 9. Which means that square root of 14 equals square root of 7 times square root of 2. So that the square root of 63 equals the square root of 7 times the square root of 9, which is equal to square root of 7 times 3, and which gives 3 square root of 7. Let's denote by A this expression. Now we replace these values in the expression A. So we replace square root of 14 by its expression to get 3 square root of 7 square root of 2 minus 4 times 3 square root of 7 divided by 3 square root of 7. Now we can take square root of 7 as a common factor in the numerator, and we get square root of 7 times 3 square root of 2 minus 4 times 3, which is 12. Now we can cancel square root of 7 from the numerator and denominator, and we get 3 square root of 2 minus 12 divided by 3. Which is equal to square root of 2 minus 4. So the answer here is D. In question 8, for x and y not equal to 0, we want to simplify the expression 27x cubed y to the 8 to the third divided by 8x to the 6 y squared to the power of third. So as a first step, we will distribute the power third in each of the numbers which are in the numerator. So we get 27 to the power of third, x to the 3 to the power of third, and y to the 8 to the power of third. We do the same thing for the denominator. So we get 8 to the power of third, x to the 6 to the power of third, and y squared to the power of third. In the second step, we will simplify each expression. So 27 to the power of third is simply the third root of 27, which is equal to 3. X to the 3 to the power of third equals x, and y to the power of 8 to the power of third is y to the power of 8 over 3. We do the same thing for the denominator, and we get 2x squared y to the power of 2/3. Now if we split this fraction in 3 fractions, 3 over 2 times 1 over x times y to the power of 8 over 3 minus 2/3, which is equal to 3 over 2 times 1 over x times y to the power of 2. So the final answer is 3 over 2 times y squared over x. So the answer here is G. Question 9. Square root of minus 36 times square root of 36 is equal to. This is a very simple question, since the square root of minus 36 equals 6i and the square root of 36 equals 6, and 6i times 6 would give 36i. So the answer here is D. In question 10, for p not equal to 2, write p minus 4 over 2 minus p divided by p minus 2 as a single fraction and simplify. In order to reduce these two fractions to the same denominator, we remark that the two denominators are almost the same, since we have 2 minus p as the first one and p minus 2 in the second fraction. As a first step, we keep the same fraction as it is, and for the second fraction, we can put minus 1 as a common factor in the denominator. So we get p minus 4 over 2 minus p minus p over minus p plus 2. So the two negative signs will give plus between the two fractions, and we get p minus 4 over 2 minus p plus p divided by 2 minus p. Once we get the same denominator, we can add the two numerators. So p minus 4 plus p equals to 2p minus 4 divided by 2 minus p. Then we put 2 as a common factor in the numerator, and we get 2 times p minus 2 divided by 2 minus p, which gives minus 2. Since p minus 2 divided by 2 minus p equals minus 1. So the answer here is C. In question 11, we should find the least common denominator for the following rational expressions. So we will be just interested in the denominators that we have. The first one, which is 6x, and which could be written in the form of 2 times 3 times x. The second one is 9 times x squared minus 1. The polynomial x squared minus 1 could be seen as the difference between two squares, like x squared minus 1 squared. So for the 9, we can write it as 3 squared, and x squared minus 1 would be x minus 1 times x plus 1. For the third denominator, it is already factorized, since it is x cubed times x plus 1 squared. Now to find the LCD is very simple. We have to write every single term with the highest power. So between the three polynomials that we have only 1, 2. For 3, the highest power of 3 is 2. So it's 2 times 3 squared. For x, the highest power of x is 3. So times x cubed. X minus 1, there is only 1, so we keep it. And for x plus 1, we have x plus 1 squared. So the LCD is 2 times 3 squared times x cubed times x minus 1 times x plus 1 squared, which is the answer C. In question 12, we want to write the fraction 2 minus 12i divided by 4i in standard form. The simplest way to deal with this question is to multiply the numerator and the denominator by I, since I times I equals I squared, which is equal to negative 1, so we will get a real number in the denominator. Now let's distribute I in the denominator. So 2 times I equals 2i, minus 12i times I, this is minus 12i squared, and for the denominator it's 4i squared. A small simplification, we have I squared equals negative 1, so the numerator will be reduced to 2i plus 12 divided by negative 4. Now if we split this fraction in two parts, we have 12 divided by minus 4, this is negative 3, and 2i divided by minus 4, we get minus 2 over 4i, which is minus half I. So the answer here is D. In question 13, we want to factor completely the following polynomial, which is 16a to the 4x plus 8a squared times x squared plus x cubed. In this polynomial, we remark that x is a common factor. So in the first step, we will put x as a common factor. So 16a to the 4x plus 8a squared x squared plus x cubed equals x times 16a to the 4 plus 8a squared x plus x squared. In the second step, we can see that 16a to the 4 could be written as 4a squared squared, whereas 8a squared x is 2 times 4a squared times x, and we keep the x squared as it is. Now, if we replace 4a squared by the letter z, we get z squared plus 2zx plus x squared, which is equal to z plus x squared. Now, if we replace z by its expression, which is 4a squared, we see that this polynomial is equal to x times 4a squared plus x all squared. So the right answer for this question is B. Question 14, we will use most of the power rules. So we will assume that x, y, and z are not equal to 0, and we want to simplify the expression 5xy divided by x to the power of negative 1 z squared to the power of negative 3 times xy to the power of 3 times z divided by 5 to the power of negative 3. As a first step, we will get rid of the negative powers if you want to make things simple. So as you see in the first parenthesis, we have x to the power of negative 1 in the denominator. So we raise it up and we change the power of x to x squared. We will do the same thing for the third parenthesis. Since we have z divided by 5 to the power of negative 3, we can see it as 5 to the power of 3 times z. In the second step, the power negative 3 will be used to flip the fraction 5x squared y divided by z squared, and we can write it as z squared divided by 5x squared y to the power of 3. Now let's write all these terms in the same fraction. So the first fraction will give z to the power of 2 to the power of 3, which is z to the power of 6, times x to the 3 times y cubed times 5 to the 3 times z, whereas the denominator would be 5 to the 3 times x to the 6 times y to the 3. Now we can simplify this fraction by cancelling y to the 3 and 5 to the 3. In the final stage, we have z to the power of 6 times z, which is equal to z to the 7, whereas x to the 3 divided by x to the 6, which gives x to the 3 in the denominator. So the right answer for this question is A. Question number 15. Which of the following algebraic expressions is not a polynomial? Actually, this question is very simple because it's enough to be interested in the power of x is a polynomial. Whereas in B, we have x to the 4 and x to the power of pi minus 1. And as we know that pi is an irrational number, so pi minus 1 also is an irrational number. So that the right answer here is B. Asked to find the degree of the polynomial x minus 2y squared plus xy squared minus 2y all squared plus y to the 5. Let's denote by A this polynomial. The simplest way to answer this question is to expand A and to write it as sum of monomials. Now A equals x squared minus 2x times 2y plus 2y squared plus xy squared all squared minus 2 times xy squared times 2y plus 2y squared plus y to the 5, which is equal to x squared minus 4xy plus 4y squared plus x squared y to the 4 minus 4x y cubed minus 4y squared plus y to the 5. Now let's write down the degree of each monomial. For the first one is 2. The second, it's x to the 1, y to the 1, which gives 2. For the third, it's also 2. For the fourth, it's x squared, y to the 4, which gives 6. For the fifth, we get 4. For the monomial number 6, the degree here is obviously 2. And finally, for the last one is 5. So as you see here, if you compare all the degrees that we have, the highest one is 6. So the degree of this polynomial is 6. And the answer is A. Question number 7. Factor out the following polynomial. 12wy plus 4wx minus 9y minus 3x. Now since we have 4 monomials here, we will proceed by grouping. So let's denote A this polynomial. Now A equals, if we consider the two first monomials, we can see that 4w is a common factor. So it is equal to 4w times 3y plus x. For the second two monomials, for the third and the fourth monomial, we can see that negative 3 is a common factor. So if we take it out, we get minus 3 times 3y plus x. Now as you see, the term 3y plus x is repeated. Now we get this term out as a common factor, and in the final stage we find that a equals 3y plus x times 4w minus 3. So the answer here is C. In question 18, we should divide the rational expression x minus 2 divided by x to the 4 minus 16 divided by x plus 2 over x squared plus 4, and we should simplify it. Now let's begin by the first step. If we divide two fractions, so we should multiply by the inverse of the second one. So we get x minus 2 divided by x to the 4 minus 16 times x squared plus 4 divided by x plus 2, which is the inverse of the original fraction. Now we can see that x to the 4 minus 16 is the difference between two squares, since x to the 4 is x squared squared and 16 is 4 squared. Now we factor out this expression and we get x minus 2 divided by x squared minus 4 times x squared plus 4 times x squared plus 4 divided by x plus 2. We find out that x squared minus 4 is the difference between two squares, and we write it as x minus 2 x plus 2. At the end, we find we should cancel some terms which are repeated between the numerator and denominator. So we cancel x minus 2 with x minus 2 and x squared plus 4 with the x squared plus 4, which is the denominator. And we get as the final answer 1 over x plus 2 squared, which is the answer B. Question 19. Factor completely the following polynomial: zx to the 4 plus 3zx cubed minus 4zx squared. We remark that the greatest common factor between the three monomials that we have here is zx squared. Let's denote by a this polynomial. So we can write a as zx squared times x squared plus 3x minus 4. Now we should factor out the polynomial x squared plus 3x minus 4. For this end, we should find two numbers a and b such that a plus b equals 3 and a times b equals negative 4. And these two numbers are obviously 4 and negative 1. A equals zx squared times x plus 4 times x minus 1. So the answer here is A. And the last question, we want to write 5 divided by x squared minus 5x minus x over 5x minus 25 as a single fraction. You know that to make the difference between two fractions, we should have the same denominator. So let's begin first by computing the least common denominator. We know that x squared minus 5x could be written in the form of x times x minus 5, since x is a common factor here. Also, we take 5 as a common factor for the second denominator, and we get that 5x minus 25 equals 5 times x minus 5. Now it's very simple to find the LCD, since it is equal to 5 times x minus 5. Now if we denote by a the expression under study, in a we have to multiply the numerator and denominator of the first fraction by 5. And for the second fraction, we should multiply the numerator and denominator by x, so that we get 5 times 5, which is 25, minus x times x, which is x squared, divided by the LCD, which is equal to 5x times x minus 5. Now we can factor out 25 minus x squared and write it as 5 minus x times 5 plus x. Divided by 5x times x minus 5. Now since 5 minus x divided by x minus 5 equals negative 1, the right answer in this question is A.